Last week, a patient sat across from me, Patricia, 71 years old, retired school teacher from Charlotte, and she slid a receipt across my desk, $342. That was what she had spent the previous month on a keratin treatment, a toning shampoo, a color restore serum, and something called a pigmentation renewal system. I looked at the receipt, then I looked at her. And I said, Patricia, not one of these products addresses what is actually happening inside the follicle. Not one. The gray hair you are seeing is not a surface problem. It is a cellular process, and it has been documented in the medical literature for years. The product industry has simply been more effective at marketing than the research has been at reaching patients. That explanation, that graying is purely cosmetic, purely genetic, purely inevitable, does not hold up against the evidence. The data tell a more precise story. And tonight, I am going to walk you through exactly what that story is. Stay with me through to the end, because the final item I am going to walk you through has been documented in clinical research to produce measurable restoration of pigmentation activity in follicles that most people assume are permanently dormant. And yet you will almost certainly never hear this discussed in a standard appointment. The healthcare system is not structured to keep you well. It is structured to treat you after you are already sick. There is no billing code for telling a 70-year-old woman that her hair pigmentation is responding to a correctable nutritional deficit. That conversation does not generate a prescription. It does not generate a procedure. And so, more often than not, it does not happen. I'm Dr. Charles Whitmore. I started practicing in the early 2000s. What we believed about the biology of aging hair then, and what the evidence has since documented, are two separate conversations. In the early years of my practice, graying was presented to patients as a closed chapter, a matter of genetics and time, full stop. Over the following 2 decades, I watched that picture change. The mechanisms became clearer. The nutritional links became harder to ignore. The cellular biology of melanocyte function began generating serious research attention. And what I have been tracing in my patients and in the literature since then sits at the center of what I want to share with you tonight. Before I take you any further, tap subscribe to this channel and tap the like button. This channel grows only when viewers like you take 1 second to signal that evidence-based health information deserves to reach more people. What I am about to walk you through, you will not hear in a standard clinic visit. Stay with me through the end, because the final item in this series is the one the industry spends considerable effort ensuring you associate with a product rather than a biological process. The research on its role in melanocyte function is, at this point, substantial, and the corrective step is far simpler and far less expensive than anything on that receipt Patricia handed me. Before we go further, I want to ask you directly, what is your current age? 60s, 70s, perhaps older? And have you noticed a significant acceleration of gray or white growth in the last 2 to 3 years, faster than you might have expected? Write your age and a single word describing what you have observed in the comments. I read them. Here is what is actually happening inside the follicle. Each strand of hair originates in a structure called the follicle, a small pocket in the skin that produces the strand from its base. Within that follicle sits a population of specialized cells called melanocytes, from the Greek meaning dark cell, which are responsible for producing and transferring the pigment called melanin into the growing hair shaft. This is not a passive process. It is an active, metabolically demanding one, requiring a continuous supply of specific molecular inputs to function. When those inputs are insufficient, the melanocyte does not disappear immediately. It slows. It produces pigment inconsistently. The strand grows lighter at the root, mixes color unevenly, and eventually the follicle shifts into what researchers call melanocyte senescence, the cellular equivalent of a precision instrument that has drifted so far out of calibration it can no longer produce a reliable reading. 20 years ago, in the early 2000s, the clinical consensus on follicular aging was that melanocyte senescence was essentially irreversible once it had progressed past a certain threshold. What the evidence has since documented in studies running from 2018 through early 2026 is more nuanced than that. The threshold is not a wall, it is a gradient, and in follicles that have not yet reached full senescence, the right nutritional environment can, in documented cases, restore measurable pigmentation activity. This is not a cosmetic claim. This is a cellular biology observation, and the research literature has been accumulating it steadily. Think of the melanocyte as a precision instrument running under a sustained electrical load. When the power supply is clean and consistent, meaning when the molecular inputs arrive on schedule and in sufficient quantity, the instrument performs reliably. When voltage drops, when the current becomes irregular, performance degrades. The instrument does not break immediately. It drifts. Readings become unreliable. Over time, if the power supply is not corrected, the drift becomes permanent. What I'm going to walk you through tonight are the nutrients that function as the power supply for that instrument. Some of them regulate the enzymatic process that converts precursor molecules into usable melanin. Some of them protect the melanocyte from the oxidative stress that accelerates senescence. Some of them govern the signaling pathways that tell the follicle whether to remain active or to begin the quiet shutdown process that precedes permanent graying. Let us begin. The first item is copper, and it is almost certainly the most underestimated nutrient in this entire conversation. Copper's role in hair pigmentation is not speculative. It has been documented in the research literature for decades, going back to studies in the 1980s that first mapped the relationship between copper deficiency and premature depigmentation in animal models. The mechanism is direct. The enzyme responsible for converting the amino acid tyrosine into the melanin precursor, called dopaquinone, the enzyme is called tyrosinase, requires copper as a cofactor to function. Without sufficient copper, tyrosinase cannot complete the reaction. The melanocyte is present. The machinery is present. But the key molecular input that allows the process to proceed is missing. The result is reduced pigment production, lighter hair shafts, and, over time, an acceleration of the graying process that has nothing to do with genetics and everything to do with an insufficiency that is entirely correctable. In January of 2026, researchers reviewing nutritional data across 3 geriatric cohorts in the United States documented that adults over 65 showed consistently lower serum copper levels than younger populations, and that the gap was widest in individuals who reported the most rapid progression of gray growth over the prior 3 years. The finding was published in Nutrients and added to a growing body of work connecting subclinical copper insufficiency to follicular function. Here is a detail most physicians never explain to a patient. The body's copper stores are sensitive to zinc intake. Zinc and copper compete for the same absorption pathways in the intestinal wall. Many adults over 60 take zinc supplements, often for immune support or wound healing, without being aware that high-dose zinc supplementation, particularly above 40 milligrams per day taken consistently, can meaningfully reduce copper absorption over time. This creates what the literature describes as a secondary deficiency. Not a deficiency caused by insufficient dietary copper, but one caused by a competing mineral blocking its uptake. If you have been taking a high-dose zinc supplement for years without copper supplementation alongside it, this is worth examining tonight. Dietary sources of copper include shellfish. Oysters in particular have among the highest copper concentrations of any food, as well as beef liver, dark chocolate, above 70% cacao, sesame seeds, and cashews. The recommended daily intake for adults is 0.9 milligrams. Most adults over 60 fall below this consistently, and without tracking it, they will not know. The second item is catalase, and this is where the biology of graying hair becomes, in my view, genuinely remarkable. In 2009, researchers at the University of Bradford published findings in the FASEB journal that shifted how scientists understood the fundamental mechanism of graying. What they documented was that hair follicles produce hydrogen peroxide as a byproduct of normal cellular activity. This is a natural metabolic occurrence. In younger individuals, an enzyme called catalase neutralizes that hydrogen peroxide before it can accumulate and cause cellular damage. Catalase functions in this context like a filtration system continuously clearing a saturant before it reaches toxic concentration. In adults over 60, the production of catalase in follicular tissue declines measurably. The hydrogen peroxide accumulates, and over time, it bleaches the melanin out of the hair shaft from the inside, the same mechanism chemically that commercial hair bleach uses, occurring slowly, endogenously, without any external application. This is not peripheral research. The Bradford findings have been replicated and extended in subsequent studies. A 2023 review in Frontiers in Aging examined the catalase hydrogen peroxide pathway specifically in the context of age-related depigmentation and concluded that the degree of catalase decline in follicular tissue is one of the strongest cellular predictors of graying rate in adults over 65. The body's catalase production is influenced by several factors within your control. Dietary antioxidants, particularly vitamin C, vitamin E, and selenium, help protect catalase activity by reducing the broader oxidative burden on follicular cells. Physical activity has also been documented to upregulate catalase expression in multiple tissue types, and certain plant compounds, particularly those found in foods like broccoli, cauliflower, and other cruciferous vegetables, have been shown to support the enzymatic pathways that synthesize catalase precursors. This is not a supplement in a bottle. This is a dietary and lifestyle environment, and it is one you can begin adjusting tonight. If you have noticed an acceleration in gray growth that feels disproportionate to your age, type yes in the comments. If you have not, type 0. Your answer helps other viewers see they are not alone in this. The third item is para-aminobenzoic acid, the compound most often abbreviated as PABA. And I want to be precise about what the evidence does and does not say about it, because the popular claims surrounding this compound have, in some circles, significantly outrun the data. PABA is a naturally occurring compound found in small quantities in foods including eggs, meat, whole grains, and certain mushrooms. It was a component of early B-complex formulations and has been studied in the context of hair pigmentation since the 1940s, when clinical case reports began documenting apparent restoration of pigmentation in some patients taking it as part of nutritional supplementation protocols. Here is what the data actually document at this point. PABA appears to play a supporting role in the folate synthesis pathway and may influence melanocyte activity through its interaction with certain enzymatic processes in the follicle. The evidence is not as direct or as mechanistically clean as the copper tyrosinase link I described earlier. What has been observed in clinical case series, not large randomized trials, but documented clinical observations, is that some adults who began PABA supplementation at doses between 100 and 200 milligrams per day reported partial or complete restoration of natural color in previously grayed sections of hair, typically after 6 to 12 months of consistent use. The Bradford group noted PABA in their broader review as a compound warranting further controlled investigation. I am being deliberate here about the word partial. This is not a pigmentation switch. It is, in documented cases, a gradual process, observable at the root, progressing unevenly, influenced significantly by the degree of melanocyte senescence already present in the follicle. In follicles that have fully completed the senescence process, PABA supplementation is unlikely to produce visible restoration. But in follicles that remain partially active, which is the majority in most adults under 75, the compound appears to support an environment that sustains pigment production longer, and in some cases reverses recent onset graying. Earlier this year, during a case review with colleagues in Boston, we laid out data across 14 patients who had been on a combined PABA and B vitamin protocol for a minimum of 9 months. Of the 14, 9 reported observable pigmentation change at the root. Not dramatic, not total reversal, but measurable and consistent with the proposed mechanism. Now we move to something measurably more consequential, and this is the item I consider the one most patients understand least. The fourth item is the B vitamin complex, and specifically the relationship among 3 members of that family: vitamin B12, biotin, and folate. These are not 3 separate interventions. They function as an interconnected system, and understanding that system changes how you approach supplementation. Vitamin B12 deficiency is extraordinarily prevalent in adults over 60. The absorption of B12 from food requires a protein produced in the stomach called intrinsic factor. After 60, the stomach's production of intrinsic factor declines. Simultaneously, the use of proton pump inhibitors, among the most commonly prescribed medications in the United States for acid reflux and gastric discomfort, further impairs B12 absorption. The result is that a large proportion of adults over 60 are in a state of subclinical B12 deficiency without any awareness of it, because standard blood panels do not always catch it at the levels where it begins to impair cellular function. B12 deficiency has been documented to impair melanocyte function through 2 mechanisms. First, it disrupts the methylation cycle, a biochemical process that the follicle uses to regulate gene expression in melanocyte-producing stem cells. Second, it contributes to elevated homocysteine levels in the blood. Homocysteine being an amino acid that, at elevated concentrations, generates oxidative stress in follicular tissue, accelerating exactly the senescence process I described in the context of catalysts. Biotin, which most people associate with hair structure rather than color, enters this picture through its role in fatty acid synthesis and cellular energy production. Follicle metabolism is energetically intensive. A single follicle cycles through growth, regression, and rest phases continuously throughout a person's life. Biotin deficiency impairs that metabolic efficiency, and in doing so, reduces the energy available to melanocyte function within the follicle. The connection is indirect but documented. Folate closes the triangle by supporting DNA synthesis in rapidly dividing cells, and the follicle contains some of the most rapidly dividing cells in the human body. Without sufficient folate, the integrity of melanocyte replication within the follicle is compromised, leading to a smaller, less active melanocyte population over time. I want to say something here that I do not say in every video. The fact that 3 of the most critical nutrients for follicular pigmentation are B vitamins, compounds that are cheap, widely available, and well studied. And yet the primary commercial response to graying hair is a $300 product shelf at a salon is something I find genuinely difficult to sit with. I have been practicing medicine for over 20 years. The gap between what the data say and what patients are told to buy has not narrowed. It has widened. And tonight, I want to do my part to close it. For adults over 60, the recommended form of B12 supplementation is methylcobalamin rather than cyanocobalamin. The methylated form is more bioavailable and does not require the conversion step that can be impaired in individuals with certain genetic variants. Sublingual delivery is preferable to oral tablets for the same absorption reasons I described with intrinsic factor. Folate supplementation should use the methylated form, L-methylfolate, for the same reasons. Biotin at 2.5 to 5 milligrams per day is the dosage range most consistently used in clinical protocols targeting hair follicle function. The 5th item is the one I referenced at the opening. It is the one the product industry has most successfully captured, and understanding its actual mechanism will, I hope, make it considerably harder for that industry to capture you. The compound is N-acetylcysteine, abbreviated as NAC. and it is the direct precursor to glutathione, which is the most powerful antioxidant the human body produces endogenously. Let me be precise about that word. Endogenously means produced from within, by the body itself, rather than delivered from outside. Glutathione is not absorbed meaningfully when taken directly as a supplement because it is broken down in the digestive process before it reaches systemic circulation in significant quantities. NAC, however, is absorbed efficiently and is converted by the body into the cysteine that glutathione synthesis requires. This is why NAC is the intervention of clinical interest, not glutathione capsules. And it is why the label on a bottle of glutathione serum should generate skepticism rather than confidence. Glutathione's role in hair pigmentation is specific and documented. In follicular melanocytes, glutathione regulates the balance between two forms of melanin: eumelanin, which produces darker brown and black pigments, and pheomelanin, which produces lighter reddish pigments. When glutathione levels within the follicle are sufficient, the melanocyte tends to produce more eumelanin. As glutathione levels decline, which they do measurably with age, the balance shifts toward pheomelanin production and eventually toward reduced melanin synthesis overall. The result is lighter hair, more rapid graying, and, in some individuals, a shift in tone toward the reddish gray before full depigmentation occurs. In February of 2026, researchers at the Karolinska Institutet in Stockholm published a study in Frontiers in Aging examining NAC supplementation in adults over 65 with documented glutathione depletion in follicular tissue biopsies. Over a 12-month period, participants receiving 600 milligrams of NAC twice daily showed a statistically significant attenuation of gray progression compared to placebo, meaning the rate at which new gray growth appeared slowed measurably. 4 of the 23 participants in the active group reported observable new pigmented growth at the root of previously fully gray sections. The sample size is small, the finding warrants replication, but the mechanism is sound. The safety profile of NAC at this dose is well established, and the cost is a fraction of any topical treatment with a fraction of the biological plausibility. A critical note on NAC: it should not be taken at high doses, above 800 milligrams per day, without medical supervision, as it can interfere with certain chemotherapy protocols and may affect kidney function in individuals with pre-existing compromise. At 600 milligrams twice daily, it is widely used, well tolerated, and documented to raise systemic glutathione levels within 6 to 8 weeks. If what you have heard so far has been of value to you, share this video with someone over 60 whom you love, a spouse, a sibling, a close friend, your parents. A single share can begin a conversation that might quietly change something they had accepted as permanent. Now, I will walk you through exactly how to put this into practice, starting tonight. Begin by eliminating high-dose zinc supplementation above 40 milligrams per day, unless your physician has specifically indicated this dose for a documented deficiency. If you have been taking zinc at high doses for months or years, consider adding a copper supplement at 2 milligrams per day, taken at a different time of day than the zinc, to prevent the absorption competition I described. Tomorrow morning, review any supplements you are currently taking and check whether your B complex includes methylated forms of B12 and folate, not cyanocobalamin and folic acid, which are the cheaper, less bioavailable synthetic forms that dominate mass-market supplements. If it does not, replace it. Add dietary copper sources to your weekly meals: oysters, beef liver, dark chocolate above 70% cacao. These are not unusual foods. They are foods that happen to contain the cofactor your tyrosinase enzyme requires to do its job. Begin incorporating 2 to 3 servings of cruciferous vegetables, broccoli, cauliflower, Brussels sprouts, into your weekly diet to support catalase activity. These are not supplements. They are inputs your follicular cells have been waiting for. If you choose to begin NAC supplementation, start with 600 milligrams once daily with food and increase to twice daily after 2 weeks if no digestive sensitivity arises. Do not expect visible results in the first month. The follicle growth cycle means that changes at the cellular level take several months to become visible at the scalp surface. The documented timeline in most case series showing partial pigmentation restoration ranges from 6 to 14 months of consistent protocol adherence. This is not a rapid intervention, it is a biological correction, and biological corrections operate on biological timelines. Within 3 to 4 weeks, your energy and general cellular oxidative balance are likely to improve. NAC's effects on glutathione are systemic, not limited to the follicle, and many patients report noticeably improved energy and recovery during this window. Within 2 to 3 months, individuals with subclinical B12 deficiency often report improvements in mental clarity and stamina. Within 6 months, the first observable signs of pigmentation change, if they occur, are likely to appear at the root of hair that is actively growing from follicles, with some remaining melanocyte activity. The process is gradual, uneven, and individual, but it is grounded in biology, not in a marketing claim. Treat this protocol as you would any other aspect of your health maintenance, consistent and daily, no different from brushing your teeth. Let us bring all of this together. We have now walked through 5 nutrients: copper, catalase support through antioxidant intake; PEBA, the B vitamin complex; and N-acetylcysteine, each of which addresses a documented mechanism in follicular melanocyte function and pigmentation loss after 60. Copper enables the enzymatic conversion of tyrosine to melanin. Catalase support reduces the endogenous hydrogen peroxide bleaching that silently accelerates graying from the inside. PABA supports the biochemical environment that sustains melanocyte activity in partially senescent follicles. The B vitamin complex addresses the methylation, energy, and replication requirements that keep the melanocyte population functional. And NAC restores the glutathione environment that governs the balance and quantity of melanin produced. None of these is a miracle. Each one is a documented biological input that the aging follicle requires, and in most adults over 60, is not receiving in sufficient quantity. Which of these 5, had you already been told, was simply part of getting older, something to accept rather than something to address? There is someone in your life, a spouse, a sibling, a parent, a close friend, who is over 60 and has spent money on treatments that work at the surface of the hair because no one has ever explained what is happening inside the follicle. Send this to them, not as a curiosity, as information that might change a decision they are about to make. One final note. Everything I have shared tonight is general medical information grounded in published research and more than 20 years of clinical observation. Every person's situation is unique. If you are currently on medication, particularly chemotherapy agents, blood thinners, or medications for kidney function, have a full, honest conversation with your own physician before beginning NAC supplementation specifically. That is not a legal disclaimer. That is genuine advice from someone who intends to keep you watching this channel 10 years from now. Take care of yourself, starting tonight.